1. This is in fact our example number 3. Okay, so I'm going to do another example. Example number 4.
Would we have to rotate the elements using 3D Mohr Circle?
3D Mohr Circle is no more rotating elements.
Okay.
3D Mohr Circle is something very useful. Okay. Okay, let's look at example number 4. Okay, so example number 4, I'm going to pick from another lecture that I did before. Okay, so summer. I could not remember when I teach 3D Mohr Circle. Okay. I'm going to take the whole thing. You know what? I'm going to copy. Bear with me. I'll be done soon. Don't worry. Copy. Okay. Let's hope that it's there. So now let me get back there. So this will be right. Okay, so this is where we are. So this example, you can see, okay, it's not really difficult, okay, but it's something that integrates everything. I'll explain to you what do I mean. So for this stress state, determine the two values of stress y for which the maximum shear stress is 75 megapascal. Repeat again, the maximum shear stress is 75 megapascal. And I want you to look at the math, okay? Okay, so you look at the math. Right, that is why I don't give you a solution manual. This is the reason why I don't give you a solution manual. If I give you the solution manual, what will happen? You're going to figure this out, right? And then when you're going to figure this out, you know, maybe the winter term will start. Okay, we're going to solve this problem. Again, this is one of the most complex problems in this topic in 3D Mohr Circle. You know what's the beauty? The beauty is we've been sitting here for 2 hours and you're listening to me blabbing. We can solve this problem without that much math. We will study better. Yeah, you don't try my technique, you won't study better, you cheeky sod. AB, Barneto, unbelievable, okay? So if you say you can study better, okay, have fun then. I'm going to stop my lecture down here. You can study this then, okay? No! I'm going to show you a technique that all you need to know is apply what I've taught you in where? What I taught you in page 1, page 2, page 3, page 4, page 5, and then you are going to do page 6. Okay? I'm going to show you now. Okay, right. Example number 4. Okay, I will give you all this example. Okay, you can have fun. Okay, I don't want you to like just look at it and not applying what I'm teaching. Now, this example, as I say, is the most useful example. Okay, so what is so useful about this example? Okay, and I know it's going to be quite late. I want you to, if it's quite late, if you're going to turn off, if you can't stand it, okay, just sit down there and listen. Okay, you can play back. We are going to relate Mohr circle with stress strain curve. Okay, we're going to relate it. Okay, so we're going to relate Mohr circle, right? So this is Mohr circle, right? So this is Mohr circle, And then we are going to relate, how is this relate to stress strain curve? Okay, so this is just the elastic region. Okay, if you go to industry, only the chief engineer is bothered about this. The rest of the engineer, not a clue. I want you to have a clue what is going on. Okay, I want you to be engineers that's capable to relate stress strain into real life. Okay, now, let's look at the numbers that are given. Okay, so we have this, we will label as our X, Y, Z. Okay, and we are told to find what is our stress Y value. Okay, I repeat again, what you cheeky start laughing out loud, we're studying. Okay, what is our two of our what stress Y value? So we know that the maximum stress is equal to 75 megapascal. That is the maximum stress that this structure can take, right? So the next thing comes is we also know that the stress max is equal to twice the radius of the circle. Right? When stress Z is equal to what? 0. So this will be equal to 150 megapascal. Okay, plus and minus. So i.e., we know at this point the stress yield is equal to what? 150 megapascal. And we know that the shear stress is at 75. Okay? Right. I'm going to draw Mohr circle. And we are going to talk about North and South Korea. Okay? North and South Korea. Unbelievable. Right. So we're going to draw. I'm going to put down my scale first. Okay? I'm going to put down my scales. So I'm going to draw a very big. I'm going to draw very big, very big. Okay? Now coming back to proctoring. Okay? So it is a fact. Okay? It's true that if the exam is proctor, it will be less difficult than non-proctor. That is the other advantage. Like why? So you guys have seen me giving your exam when it's non-proctor, right? And you can see how I change the numbers. Okay. Sometimes changing those numbers might not be fair. I'll tell you. Okay. Sometimes it gives students like, hey, this number, have 666. I don't like that number. You all get what I mean, right? So why we have the different numbers so that you all cannot what? Compare. And I know that a lot of you did not compare. I know that. Okay. By marking, I know a lot of you are honest. Okay. And I know some of you are not. How I know a lot of you are honest is where your grade for term test 1 and term test 2, they are about the same. Okay. If you do better, good. The holy shit comes when you do worse. Now I don't know whether you understand or you don't understand. That's my problem. So when it's proctor, okay, the numbers will all be the same. When it's non-proctor, I don't ask you things that you can get from your textbook or from your internet. I will make sure that you think. I will ask you question to kill your gray cells, to kill your to make you think. Okay? So I will not ask you question like simple question like what is the radius of the circle in Mohr circle? You can know. I can look at his lecture and tau max, right? Right. I will not make you ask you question for you to remember stuff. Okay. I will always ask you question to analyze. Okay. Is the analysis that is more difficult than anything else in any subject? Okay. So for a proctor exam, we can ask you 30% for like memory. Okay, can you remember what is the radius of the circle? So the software will look into your eyes, make sure you're not copying, and so on and so forth. You write down, oh, the radius is out. Simple marks. You can get up to 20 to 25% on it. If not, it's like my strength of material, like what you're going through now. I don't ask questions that you can find formulas or find solution from the internet deliberately. Okay, because I have to be fair to who? I have to be fair for the student that work really hard. Okay, those that work really hard, I have to, my salary is paid so that I can uphold the what? The fairness. Okay, the fairness. Right. I'll come back to that later when I think you guys were more interested in that than the bloody Mohr circle. Am I right? No answer. Right. Yes. Unbelievable. Right. So element rotate clockwise, element rotate anti-clockwise. Okay. So what we have now, right? So I'm going to incorporate this into the Mohr circle now. Okay. I'm going to incorporate, and you don't get a lot of this type of combination at all. Okay. So I'm going to draw a space. Okay. And this space is like the border between North and South Korea, the demilitarized zone. Okay, you go beyond that, you die. Okay, so there you go. So this is the outside this box is known as the demilitarized zone. You go there, you die. Okay, so this is the box. So what we have just done down here, we have incorporated U strength in normal stress and shear stress to a 3D Mohr circle. This is real life now. So what do I mean? So we know the top down here, this value is 75 megapascal. Okay. Down here is also 75 megapascal. Right? And we know we have an anchor. Okay. The anchor point is where stress Z has to be equal to what? 0. Okay, so this is our anchor point. So the most this circle could do is what? 150 megapascal positive and negative 150 megapascal. The most. Why? So if I draw the circle now, it has to pass through stress Z point. Right? So this is one part of the circle. This is the most the circle could go. Because the stress Z or point Z is the anchor point. So where's point Z down here? This is my point Z. Is the anchor point. The circle that you draw cannot leave what? Point Z. You can draw a bigger circle, right? Yeah, but if you draw a bigger circle, good luck. And the other anchor point, the other side, the minimum, also has to pass through what? Point Z. So point Z is the anchor term. That is why we say the maximum stress is equal to plus or minus what? 150 megapascal. No more, no less. If you don't have stress Z, then you can. But the stress Z is the holding point. So number 1. Okay. So now, I'm going to get rid of this now. Okay. So and if your circle go beyond this point now, if your circle go beyond here, your material will yield. Okay, the material will yield. When I say yield, means it go into the what? The plastic region. For ductile material. For brittle material, it might even break. Okay, so your circle cannot go out there. Okay, it's no man's zone. It's no man's territory. So this is how we combine Mohr circle with material handbook data. Okay, this is how you combine it. Okay, and it's critical. I want all of you from this program to be able to relate what you get from material handbook and how you relate to Mohr circle, 3D Mohr circle. Okay, now So the next step is still the same. Nothing changes, okay? I'm still going to do what I've done in the past 5 pages, okay? So we are going to draw our, so it's going to be minus 70